It's time in the course where we start looking at metric prefixes and scientific notation as the numbers start to get large. It's a fairly simple concept. Any measurement in metric usually has three parts to it. There are the units being measured, the amount in the actual number, and we have a multiplier or some sort of prefix that is multiplying that number. It is exactly the same as money. You've been doing it your whole life. You just didn't realize it. We measure money. It's just weird we put the dollar sign up front. We have an amount of bills, and then we may have the size of a bill. So $210 bills versus $205 bills would be a similar concept in money compared to measurement. K or kilo means 1,000. In money, we have a nickname called a grand. 200 kilograms could be called 200 grams. And 200 grand could be called 200 kilodollars. The metric prefixes that we use are milli, centi, deci, and typically kilo, mega, giga, tera. We will touch on micrometers later, but that's more of a biology thing. It's interesting that deca, for decade or 10, shows up in words decade, decathlon, decapitation, and deca-caffeinated. No, not every word with deca in it means a tenth or 10. Money has unofficial prefixes, and they're quite random. If you say I made $3,000, you know it means times 1,000, so it's $3,000. The slang grand functions the same as kilo in metric. Rarer terms for money include the C note, which is hecto, and sawbuck, which means 10. The bill size is called its denomination, the name of the bill, literally. You routinely convert between them, but once struggled with this idea. If you can handle 20 $10 bills is the same as two 100s, then you can do metric. Here are some of the disappearing nicknames for money. Fin, sawbuck, C note, grand. You have to be like over 60 to use the top three. And there is no prefix on a 1, but we've nicknamed it a loonie and a toonie. These are denominations that have no metric equivalent. Some are still in use around the world, some are not. Some country thought it was good to have like an $89 bill. It's some really strange one. And Canada, honest to goodness, has a threenie. We have a loonie, toonie, and threenie. There is no short form for 3. So these would be non-metric denominations because they are not nice multiples of 10 that we have named. Here are 3 denominations in Canadian currency. 3 $1,000 bills is 3,000. 3 $100 bills is 300. 3 $10 bills is 30. You have the amount and the denomination. This is 1,000. This is in multiples of 100 and multiples of 10. As the face value shrinks, the amount of money you need to have the same amount of cash grows. So if you want your money converted from $1,000 bills to $100 bills, you're going to need more of them. So 3 $1,000 bills, if you switch the bill size to hundreds, you're going to need 30 of them. If you switch the bill size to 10, you'll need 300 of them. In metric, we don't say tens, hundreds, and grands. We say deca, hecto, and kilo. Deca and hecto have largely disappeared. People don't find them useful. In money, we would say, hey, give me 300 sawbucks. Well, I got 30 C notes. Will that do? Oh, how about $3,000 bills? Give me 3 grand. That would be the equivalent in money. Let's take a look at this a bit further. 50 times 10 would be 500. 5 times 100 would be 500. And half of $1,000 bill would also be 500. But you are not allowed to chop a bill in half to split it up. In ancient times, when the money was actually coins, you were allowed to cut the coins apart if you needed to, but not anymore. Half a grand is the same as 5 100s. What if I order you to give me the money in specific denominations? I want 3 hectodollars from you, but I insist that it comes in units of 10. What would you do? Well, the face value has gone down. The multiplier is 10 times smaller, so you would replace it with 10 times more. You're just shoving the zeros back and forth from the denomination size, which is our prefix, to the actual count. So 30 dams would be the same as 30 You get that? 3 is the same as 30 dams. 30 decameters is the same as 3 hectometers, just like 3 $100 bills is the same as 30 $10 bills. What about converting to base units? Base units mean you want everything in loonies. You want them in $1 increments. So a base unit, you simply remove the prefix and just write the number out in its full size. So 2 tens equal 20, 4 100s equal 400, 3 5s is 15, and 4 toonies is 8. Okay? So 2 tens is 2 decadollars. 3 5s is just 3 5s because we don't have a prefix for it in metric. 4 100s would be 4 hecto. 5 thousands would be 5 kilo. But we do not have a multiple for 5 in metric, so there's no short form. Sure, in money we could say this is 3 fins, but the metric people never picked a multiple of 5 to give it a name. So we really don't want to use multiples of 5 if we can avoid it, because we can't create a short name. And remember, the H is hecto, not hours here. And that's how you would get rid of the prefix if you needed to. When you want to get rid of the prefix, you simply remove it by executing it on your calculator. So if I asked you for 5 millimeters, the first thing you do is replace the short form with the prefix, 5 times 10 to the minus 3. To get rid of the 10 to the minus 3, we are going to have to execute it, meaning take away 3 zeros off that number. So in preparation to do that, I write a bunch of leading zeros in front of the 5, and then we're going to move the decimal 3 places to the left. 1, 2, 3, and 5 millimeters becomes decimal 005 meters. Now on any calculator, you could simply execute that by typing it in on the calculator itself. If I write 5,000 meters and you want to put a prefix on, you notice, oh, there's 3 zeros right there, and 3 zeros actually has the name kilo. So I can write it as 5 times 10 to the 3 meters by collecting it and then realizing it, hey, there's a short form for it. K, I've got kilo now. switching between the free prefixes in money, you do it so often you probably don't even recognize that you're doing it. You could easily break 2 10s and a 20, no problem. But when I switch it to metric, it sometimes causes a conversion. If you were not comfy with the switch, you could convert everything to baseless or prefixless versions. You could say, I don't know how to break a 20 for 10s. And I'm like, I'll tell you what, everybody, convert your money to loonies. The person with 2 10s gets 20 loonies. The person with $20 bill gets 20 loonies. And then you would see that it's equivalent. Now the idea is, can you make the leap without converting everything to a base number first, without that change to 20 loonies? And the answer is yeah, you already know how to do it. Let's put it all together here. When we go this way, the bill size is getting larger. And when we go this way, the bill size is getting smaller. So we have denominations of 10, 100, 1000. Deca, hecto, kilo. Canada does not have $1 million and $1 billion bills. We don't have a tenth of a penny or a thousandth of a penny. Okay? The penny was the base unit of currency, but metric, it's unitless. This is where the loonie would be sitting, in no multiplier at all. So metric spans more than money, and of course metric misses piles of money in between. But if you think about money, if I want you to change pennies to $10 bills, because the face value on the bill got bigger, the number you need shrinks. So as bill size get larger, the count of bills you need goes down. If you decide to change a $1,000 bill to dimes, well, the number you're going to need goes up. It's exactly like money. And so what you can do is count how many steps over you've moved to do this. If I want to switch from $1,000 bills to hundreds, I add a 0, then another 0, then another 0, and I get 100,000 loonies. I keep going to dimes and pennies. You're just adding and subtracting zeros in each direction. It's not a bad idea to write this chart down and bounce back and forth until you're comfy with it. Now, what if we wanted to go from micro to mega? We are missing several prefixes here. Notice I said multiply or divide by 10 with each step, but all of a sudden the steps leap. They're no longer changing by 1 0, but by 3. So in other words, we have a prefix for 1,000, a prefix for 1,000,000, but nobody thought to add a prefix for 10,000 or 100,000. We have a prefix for 1,000th, but not 1/10,000th. It starts to jump by 3s. Now, you should eventually have these prefixes committed to memory by first year university. It will make life go a lot easier. Trillion, billion, million, thousand, hundreds, tens, ones, tenth, hundredth, thousandth, millionth, billionth, trillionth. If you want to replace the prefix and get rid of it, simply change the letter to the prefix and write it out if necessary. But this number is going to start getting crazy. But don't take the power of 10 off if you don't want to be writing zeros all day. 19 micrometers would turn to 19 times 10 to the minus 6. 76 centimeters would switch to 76 times 10 to the minus 2. 5 millimeters, 9 hectometers, 120 nanometers, and so on. What if we want to deliberately add a prefix or convert it? Let's say we want to do 18 kilometers to centimeters. 18 kilometers turns to 18 times 10 to the 3 meters, or 18,000 meters. Now to turn that into centimeters, we are adding a prefix that is going to shrink the number by 100. So we must counteract that. It seems stupid at first that we would deliberately add 2 more zeros to the prefix to put the centimeter on. But you do this all the time. If someone said, can you convert this $10 bill into loonies? You'd go, oh, here's your 1 loonie. It's like, no. I said I wanted it in smaller denominations. So when I give you a 10, you cannot give me a loonie. You shrank the size of the money by 10. You got to give me 10 loonies to be the equivalent. And then you go, what's the point? Well, you felt like having it in loonies. So if you really need kilometers written in centimeters, this is how you do it. You don't do it just for the sake of it. You do it when you need it. You ask someone to go find the height of the CN Tower, and they come back and go 500,000 millimeters. And you're like, I didn't want it in millimeters. How long did that take you? Okay? So when you decide to switch money from $20 to 20 cents, you can't just change the multiplier. You got to change the number of them, or you will not have the same amount of money. Okay, there's your introduction to metric conversions using money, and that's all I have to say about that.